couple things. First being angle side theorem and hypotenuse leg theorem. So before we can do all that, one of the things that we do want to talk about is the third angle theorem. And if you know anything about triangles, the angles all add together to give you 180 degrees. So if I know all three angles, angle 1 plus angle 2 plus angle 3 equal 180, let's think about that. And if I know angle 1 and angle 2 are the same in both triangles, so they're still the same measure in both triangles. So whatever it is, if I subtract angle 1 from both sides, and if I subtract angle 2 from both sides, then that means angle 3 can only be one measure. It can only be one answer, because all three of them have to add together to give you 180 degrees. So if all three of them add together to give you that, and you know two of the three, then the third one must be equal to whatever the third angle is in that triangle, because they all have to add together to give you 180, and if two of them are the same, then the third one has to be the same as well. And that's how you would go about proving it. Not that we're going to prove it, but at least understanding that if two of the angles in a triangle are congruent to two of the angles in another triangle, then that third angle must be congruent. Now, one thing I will talk about, though, is I can draw a triangle that has a 25-degree angle and a 35-degree angle, and this triangle is not congruent. It's not the same size as this triangle right here, because that triangle is much tinier than this big green triangle. So when all three angles are congruent, we have similar figures, but we cannot prove that they are congruent figures. They're only similar because one's bigger than the other. Okay? All right, so then let's talk about the angle side congruence. When we look at this, what we are looking for is one angle equal to another. So we could say like angle A is congruent to angle, let's call it Q. Then we're going to need another angle. So another angle altogether. And we'll pull this top one and call it B. And then since we're doing Q, let's do R. So angle B is congruent to angle R. And then the last thing that we need to do is take a side. And since we're doing AB, we'll go to C, Q, R, S. So then that means that BC must be congruent to RS. Because as we go in a clockwise or counterclockwise motion, doesn't matter which direction you go, you can feed yourself this way or you can feed yourself the other way. It doesn't matter, just as long as you end up getting to the result. So when I do this, I see angle, angle, side, angle, angle, side. So that means that these two triangles, triangle ABC, is congruent to triangle QRS. Now be careful, because if we were to have those same two triangles, okay, and we had angle A is congruent to angle Q, and B is congruent to angle R, and then this is S and this is C. But if this is the one that's marked off that's congruent to that, that is not true, because we would go angle, angle, side, angle, angle, side. This one's going side, angle, angle, which you could say side, angle, angle, but then it better be side, angle, angle. You can't hop a 1 to a 2 mark to a 3 mark and go 3 mark, 1 mark, 2 mark. It doesn't work that way. You really have to, as you go along, progress in a clockwise or counterclockwise motion. I don't care which one. But if you're going to do it, then they all better be there in the same spots. Okay? So please pay attention to that. These are not congruent over here. So I'm going to get rid of them. Okay. So let's look at this. So think about this then. So if we have angle, angle, side, and angle, angle, side, you can rotate through it. See the first angle here is equal to the first angle there. So angle X is congruent to angle Q. And then the second angle is going to be angle Z is congruent to angle T. So angle Z is congruent to angle T. And then we need a side. So that side better be connected to this last letter. So we better have a Z is congruent to a T. And obviously we need the other letter, but you better have those letters in it. So whatever you did for the next one, you need to have for that one. So we'll go Z to Y, and we'll go T to R. And those are segments. Oh my God, thank you for the likes. Appreciate it. So then we can prove that triangle XZY is congruent to triangle. So if we do XZY, QTR, use what you have to help you out. If I said X to Z to Y, Q to T to R. Follow that pattern. And yeah, I'm freezing in my house because my wife won't turn on the heat. So yeah, I've got a sweatshirt on. I've got a winter hat on. I can still hear through my cans, but man, it's cold in my house. All right. So this is how you do that. And you can do it with numbers just as well as just symbols. So check this out. Oh my God, thank you for all the likes. We have angle R is congruent to angle K. You can see they're both 46 degrees. So I'm going to say angle R is congruent to angle K. Then I'm going to move on to the next one. We're going to say 62 is equal to 62. Okay, we can go with that. So angle P is congruent to angle M. And now we've got a side. And we have a third side. Now, I do notice, and I recognize that we're going this way in one of them and this way in the other, and it's not the same direction. But we are hitting the same colors in the same order. So we're okay as long as you do that. Even though one looks like it's flipped over, it is reflected. But that doesn't mean that they're not congruent figures. They're still the same size, shape, everything else. Because we can prove all of this stuff. And I'm going to say, for the last one, we're going to go P to Q, and we'll go M to L. So we'll say P to Q segment is congruent to M to L segment. So then triangle RPQ, so R to P to Q, KML. And why do we know that? What's our justification for that? Angle, angle, side, congruence. Same thing here. Angle, angle, side, congruence. And this is justification. Justification. Okay, so now this is where I was going to tell my students to give this a try. So you go ahead and try this. And then I was going to have a group activity. But I'm not going to do that with, obviously, my stream. But you can practice this one as well for angle, angle, side. But go ahead and try this one. So let's take a look. What do we have? Well, we can definitely see angle Y and angle T. So that's a good sign. Angle Y is congruent to angle T. Then we better come up with another angle. Where could we see another angle? Yeah. We have vertical angles here. We have vertical angles. They are angles formed by two intersecting lines, and they're across from each other. So I can literally say, well, I don't want to say angle Q is congruent to angle Q, but we'll start with Y, go to Q, and then go to X, so that we create that angle. So angle YQX is congruent to angle. Well, if I go Y, remember that's yellow, so I have to go T to Q to R. T to Q to R. And we would say that is because of vertical angles. I know we haven't been doing justification, but because everything's been given to you. If the picture tells you, that's given information. So there's not a whole lot I could write to justify that, but we can for this. This is vertical angles. They're directly across from each other, and the highlights show that. And then the last one, we know QX and QR are congruent, and we know that because the picture tells us. So we're going to go QX is congruent in segment, and we're going to go QR. Oh my gosh, thank you for the likes. I truly appreciate all of that. Thank you. So Q to X, Q to R. And we know this because it's given. Thank you again. And that's just because the picture has it on there. If the picture has it, that's how we roll. So now we can say triangle and use your angles. You don't even have to recreate the wheel. You already did it. YQX is what you use for angle. It's congruent to triangle TQR. And you don't have to worry about the order because you already paid attention to that. We went yellow to blue to nothing, yellow to blue to nothing. So we already did that, and we can say it by angle, angle, side. Okay? Once again, we still have that vertical angle issue, so this is still going to be equal to that. So we'll start with RPQ. So R to P to Q. Now remember, when we go to Q, we're going to the 27. So that should be the last thing that we touch. So if that's the case, then we need to start at H, go to P, and then go to G, because the last thing, RPQ, we touch 27. HPG, we touch 27. So that's how I know that it's HPG. And I promise you, you will get points docked from teachers if you don't go in the proper order. And we can say vertical angles, because those are directly across from each other. So if I highlight, and I apologize to people on the phones that it's slid over and can't see much. I don't know how to fix that. Then we're going to go angle. And this time, there's only one angle at these, so we can go angle Q, angle G. So angle Q is congruent to angle G. And that's given because the numbers are equal. And understand, there is a bit of a process. You would say angle Q is equal to 27, angle G is equal to 27, therefore angle Q equals angle G by the transitive property. We're going to trust that you know 27 is equal to 27. But if you were writing a real formal proof, that's how you would have to do it. So just understand that. When the guy on TikTok said all I had to do was this, no, it's a little bit more complex than that, but there's not a lot of proofs going on unless you're in college. So we're going to stick with 27 is equal to 27. I can see that, so angle Q is equal to angle G. Give it. All right, side. QR. Q to R is congruent to G to H. And that's because I start at green and I go the other direction. I got to start at green and go the other direction. And you can say this is given as well, just because we know 8 is equal to 8. I don't really need to prove that, but you can if you need to. And then go back up to the first one we wrote and change angles to triangles. And we can say angle, angle, side. Hopefully that sticks with you for the angle, angle, side stuff. And like I said, try these. Pause the video, give them a shot, see if you can do the same thing. But we're going to move on to what they call the hypotenuse leg congruence theorem. And what that means is there's a couple things. First off, first and foremost, we need a right angle. And a right angle is 90 degrees. And 90 degrees is also indicated by a box in the corner. So there better be a box here. If there's not a box here or 90 degrees, you can already stop the hypotenuse leg theorem because it's done. Okay? Next, once I do that, you heard me, we have the hypotenuse leg theorem. So what I must know is that my hypotenuse, which is the side across the 90-degree angle, so the side across from the 90-degree angle, that is my hypotenuse, needs to equal the hypotenuse. So these two have to be the same measure. Okay? And then after we do that, then all we need to know is a leg and a leg. That a leg equals, or we can put congruence, congruent to another leg. Okay? If we can do that, we can prove that these two triangles are congruent. Okay? So this is called the hypotenuse leg congruence. So what we need first, is there a right angle? Is there a right angle here and here? That has to be your first check mark. If it's not, then we might as well just stop. We don't need to do anything else. Okay? Now, next thing is, can we show E to C is the same as L to K? So E to C, is that congruent to L to K? And it is, because both are equal to 8.3 meters. All right, then the leg is going to go 90 to, not 90, so we'll say D to C. So D to C is going to be congruent to M to K. And why is that? Because both are equal to 5.6 can't say that, because 5.6 and 6.1 are not the same value. So these are not, we can't prove it by hypotenuse leg. Okay? So, where's one we can? Look at this. First things first. 90-degree angle, 90-degree angle. Check it off your box. Next, hypotenuse. DFAC. We'll start with AC. We'll start with the one on the left first. So AC congruent to DF. That does check out because of the two markings. Two marks. We could call it given, but let's start to actually be a little decisive with our thoughts and say exactly what it is. So B to A is congruent to E to D because of the one mark. Because this one mark and that one mark. So then we can actually prove that triangle BAC is congruent to triangle, and we went pink to green to nothing. So B to A to C, so E to D to F. By the hypotenuse leg theorem. Excellent. Hopefully that was okay for you. Let's move on to this one. Now, this one's a little trickier because first off, let's do our normal 90 degree. So far, so good. But the hypotenuse, we want to show that CA is congruent to EG because both equal, but there's no value here. This one's 13, so we need them both to equal 13 in order for that to work. Well, in order for that to work, I need to use the Pythagorean theorem. So I've got to go into my bag of tricks. I've got to use a squared plus b squared equals c squared to find what c is in this triangle. So a squared plus b squared equals c squared. And the only letter I ever care about in the Pythagorean theorem is c, because c is always across from the 90-degree angle. And you're like, well, Schmidt, what do you mean and all you care? Well, think about this. What is 2 plus 3? What is 3 plus 2? In both cases, you get 5. So it doesn't matter which one of these is A or B. The only thing I care about is we set it equal to C. So C is the most important. And we can call this A, we could call this B, or switch them. Doesn't matter. So I'm going to do 5 squared plus 12 squared equals C squared. 25 plus 144 equals C squared. 169 equals C squared. Now, to get rid of a squared sign, my brain must do the square root. And whenever my brain comes up with that, I have to put plus or minus, but there can only be a positive value for length. So I really only care about the positive answer, but C is going to equal 13. So they both equal 13. Now I'm still rolling. This is still 13. I'm still good. Still making my way. Now, the last one is I want to show that FE... Oh, no, I can't show that. I suppose I could, but I'm not going to. Because that's a little bit more work. B to C, F to G, aren't they both 5? So because they're both equal to 5, I can say B to C is congruent to F to G. And I'm just going from the 90 away, 90 away. So that's why I knew. So now I can say triangle CA, so CAB is congruent to triangle EGF by the hypotenuse leg theorem. Awesome. And then here's a couple more that I would have my students do. But hopefully you can recognize that the 90 here, the 90 here. Here's my hypotenuse for both of them, which is equal on both of them. So then I just have to find this side or that side and make sure this one is a 3 because it's in this triangle. Or this one is a 4 because it's in this triangle. And the reason I say that is because if this is 3, that has to be 4 if they're going to be equal. And if this is 4, that has to be 3 in order for them to be equal. Well, luckily enough, 3, 4, 5 is what we call a Pythagorean triple. Because square it, square it, square it, 9 plus 16 is 25. So it's a Pythagorean triple is what we call it. So 3, 4, 5 is a Pythagorean triple. What is it? 6, 8, 10. Because 36 plus 64 equals 100. So these are just types of what they call Pythagorean triples. But they're perfect squares with integers. So we don't have any decimals or square roots in it. It's just literally 3, 4, 5, 6, 8, 10. I know those are what they consider Pythagorean triples. Okay, so once I know that, I do know that I have the hypotenuse is equal to each other because it's the same line. I know they're 90-degree angles, and I know one of the sides is equal because actually all 3 sides are equal. Boom, there it is, done. Holy cow, what the, oh my gosh. What are diamond, holy goodness. I don't even know what they are. Thank you. Glitters? Holy good gracious. Amazing. And Becca sent me a ghost? Hell yeah. Thank you, thank you, thank you. Oh my God. All right, I'm not going to go through that proof. You can work through it just like we did all these other ones. Keep working through them. And then the last one, Hypotenuse is 15. Hypotenuse is 15 because it's across from the 90-degree angle. That's why I know it's the hypotenuse. And then look, they both have 12 because 12 is in the top triangle and 12 is in the bottom triangle. I've got right angles. I can promise you this one is hypotenuse leg as well. So go through the proofs, make sure you can do them, and be successful. Please, I just actually got done with the session today. We did, so in my tutoring chat, we worked on it. We worked on a Canva together, and I posted the Canva link to them so that they could look through it. All the work we did in the hour together. So it's great things. I hope people are understanding math a little bit better these days. There's so many resources out there. I just want people to be successful in doing math and not hate it or not. I'm not a math person. I'm not a numbers person. You know, I've heard that my whole life. I've been teaching for 20 years, and somebody says it every year. So please don't be that one. Get the help you need. Okay? Have a blessed day. I got